Recursion is a word used to strike fear into the hearts of new programmers. It's a simple concept that just takes a second to learn how to use properly. Recursion is just when a function calls itself. Now, that might sound fairly straightforward, and it is, but it is one of the hardest concepts for new developers to learn. So don't beat yourself up if it takes just a little extra practice and a few more examples before you fully understand what's going on. Let's take a look at this simple example. We've got a function called countdown, and it takes as input n, an integer. First, it just prints n. After it prints n, it calls itself again, but only after subtracting 1 from n. So what happens if we call countdown and pass in 5 as n? Well, first, 5 is printed to the console. Then countdown is called again, but this time with n-1, or 5 minus 1, which is 4. So we go back to the top of the function. Now we'll print n, which is 4. All countdown again, this time with 3, and on forever. So we've figured out the recursive part, but the problem is this function will never stop.
I can't stop.
It will keep calling countdown over and over and over, decrementing by 1 every time, even into the negatives. Countdown with -1, -2, -3. So what we need is a base case to stop the recursive madness. Let's add an if statement to the top of the countdown function. If n is less than or equal to 0, instead of printing n and recursing again with n-1, we'll just print the word blast off to the console and return immediately, again stopping the recursion. So what happens now if we call countdown with n of 5? First, 5 is printed, then we call countdown again, and that's because 5 is greater than 0, so we're not going to trigger that base case. Next, countdown is called with an n of 4. Again, we're skipping the base case because n is greater than 0, 4 is printed to the console. This continues all the way down until n is less than or equal to 0. So when n is 0, we'll enter that if statement, print blast off, and then return. And because we're returning, there will be no more recursive calls to the countdown function. So the final result is that when we call countdown of 5, 5, 4, 3, 2, 1, blast off is printed to the console. Now let's take a look at one more example. Let's say we want to write a function called dict_depth that returns the depth of an arbitrarily nested dictionary. For example, this dictionary only has a depth of 1. It has 2 key value pairs, but there's no nested dictionaries within it. But if you take a look at this dictionary, it has 3 nested levels. Melee weapons corresponds to a second dictionary, which has the key stabbies, which corresponds to another nested dictionary, a total of 3 levels. Now, because the dictionary passed into our function can be arbitrarily deep, recursion is a really good fit for this problem. So let's figure out what our function signature should be. We'll define the new function, we'll call it dict_depth, and we'll pass in 2 parameters, d, the dictionary itself, and then max depth so far, which is just going to keep track of how far into the nested dictionary we are at each level of recursion. Now this time, let's start with the base case, just so we have a different way of approaching this problem. And our base case should be when there's no more dictionaries to recurse into. So if d is not a valid dictionary, for example, if it's just a number, like the number that corresponds with the Bose key, 6, then we're going to stop recursing. So we'll just add this if statement that says, if d is not a valid dictionary, immediately return the max depth so far. Okay, now we need a recursive case. We need to figure out how to go from the top level dictionary to the next level nested dictionary, or dictionaries, because there can be multiple key value pairs. So first, we'll set a current max variable equal to the max depth so far. And the purpose of this variable will be to keep track of the max depth of all the nested dictionaries at this level. Next, we need to iterate over each potential dictionary at this level. In Python, there's a .values method that we can call on a dictionary object to get every value in that level of the dictionary. Now, at each key value pair, we'll recursively call dict_depth, but this time we'll only pass in that nested dictionary. So instead of passing in d, we're going to pass in v. We also need to increment the max depth so far by 1 because we're going 1 level deeper. Now, once that recursive call returns, it will return with the maximum depth of that sub dictionary. So we should track that max depth. And at the end of the loop, if that max depth is the greatest of all the nested subdictionaries, that will be the one we'll return. So with the first call to dict depth, we're going to pass in a dictionary, D. It has 3 layers. The first level has melee weapons as a key, which corresponds to a single dictionary. It's the only key at the top level. The second level has 2 keys, stabbies, which corresponds to a third dictionary, and bows, which just corresponds to the number 6. Going down into that deepest level, we've got a dictionary with 2 keys again, spears and knives. Spears mapping to 4 and knives mapping to 3. We also pass in a max depth so far of 0, just because this is the first call. So what happens? Well, first, in this initial call to dict depth, the base case is going to be skipped because we've passed it a valid dictionary. Next, we'll set the current max to the max depth so far, which is 0. And that will be overridden within our loop if we find a recursive call that returns a greater number. Now we iterate over all the key value pairs in the dictionary, which in this case is just the melee weapons key. We enter the recursive call where we pass in the dictionary that corresponds with the melee weapons key, that subdictionary. We also increment the max depth so far to 1. Within that recursive call, again, D is a valid dictionary. We'll set the current max to 1, which is what the max depth so far was. Then we'll iterate over each key value pair again. This time there are 2. The stabbies key and the bows key. Because the stabbies key is first, we'll start there. We'll kick off another recursive call, this time passing in the dictionary associated with the stabbies key. We'll also increment the max depth so far to 2. We'll iterate over each key value pair. Again, there are 2, spears 4 and knives 3. Starting with the spears key, we move into another recursive call. This time, the value 4 is not a valid dictionary, so we trigger the base case and immediately return 3, which was the max depth so far that we passed in after incrementing it. Now we're back up a level after returning 3. We move on to the next key in the dictionary, the knives key. Again, it kicks off a recursive call. The max depth so far, again, is 3 because we've incremented it from its parent function where it was 2. Again, D is not a valid dictionary, so we'll immediately return 3. Now, back up again in that parent function. We've iterated over both key value pairs, and we're going to return the maximum of the 2 return values, which because they were both 3 is just 3. So that will return up the call stack again. Now we're back into the second call. There's another key for us to process, the bows key. That will kick off a recursive call. This time, D, again, is not a valid dictionary. It's just the value 6. So we'll return 2, because 2, again, is incremented from this call's parent function where it was 1. Now we've iterated over each key in the dictionary, the stabbies key and the bows key. The recursive call to the stabbies key returned to 3, while the recursive call to the bows key returned to 2. So this call, which will return the maximum of the 2, will return a 3. Now we're back in the original function. We've iterated over all the keys, which in this case was just the melee weapons key and its associated dictionary, and we'll return 3, and the recursion is done.